Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. We use the statistic number of registered doctors, dentists, nurse and community nurse by state in Malaysia 2050. My name is Engku Nashatwani binti Engku Ahmad. The metric number is A20A1323. For the first slide, we can see the objective. The first objective is organizing data number of registered staff type at hospital in Malaysia 2050, and the second objective is checking the relationship between two variables that are hospital and state. Data description. Descriptive are tabular, graphical and numerical summaries data, and the purpose of data descriptive is to facilitate the presentation and interpretation of data. Data set for statistic number of registered doctors, dentists, nurse and community nurse by state in Malaysia 2050. Okay, for this data, we choose randomly 5 states such as Johor, Kedah, Kelantan, Melaka and Terengganu for the data. Okay, for this slide, we can see the schedule of the number of registered doctors, dentists, nurse and community nurse by state 2050. The type of variables is state, government and private, and we using the quantitative data that is numerical. So this is data engagement. The step 1, we use formula number of classes. K is 2K greater than N. 2K greater than N. So the N for this data, we have 40 data. So to get the greater than 40, we use 2 powers of 6, we get 64. 64 is greater than 40. So the number of classes is 6. Step 2 is determine the class width. The formula of class width is maximum entry minus minimum entry divided by number of class. So 6,441 minus 2 divided by 6, and we get 6,433 after minus 2, and divide by 6, we get the 1073.167. After round 8, we get 1074. And the step 3 is set the individual class limit. Upper limit of first class is for this data is 1075. And want to get the upper limit of the other classes, we also plus 1074. So the upper limit first class is 1075, and we plus 1074, we get 2149, and after that 2149 plus again with 1074, and we get 2150, and so on. Step 4 is make a tally mark of each data entry in the appropriate class. And the step 5 is the number of the tally mark for a class is the frequency for that class. This is tally and this is frequency. The frequency of data is 40. Thank you from me.
The relative frequency distribution is the position of percentage of the data that falls in that class. To find the relative frequency of a class, divide the frequency by the sample size n, which we get 0.55, 0.3, 0.075, 0, 0.05, and 0.025. Meanwhile, the cumulative frequency distribution of a class is the sum of the frequency for the class and all previous classes, which is 2 until 1075 is 22, 1076 until 2149 is 34, 2150 until 3223 is 37, 3224 until 4297 is 37, 4298 until 5371 is 39, and lastly 5372 until 6445 is 14. The cumulative frequency of the last class is equal to the sample size n. Next is graphical representation. First graph we are using histogram. For the formula of midpoint is lower boundaries plus upper boundaries divided by 2. From this histogram of register of government and private community in hospital, we are using midpoint as x-axis where the number is taken from class interval, while for the y-axis is taken from the number of frequency. By follow the table, we can say that class of 2 until 1075 is higher than other class, which is 22 of frequency. The next graph we are using is OGIF. From this OGIF of register of government and private community in hospital, we are using upper boundaries as x-axis where the number is taken from class interval, example 2 plus 1075 divided with 2 and followed by other class, while for the y-axis is taken from the number of cumulative frequency, which is the adding number from frequency.
Hi, my name is Li Xueyin. My number matrix is A20A1412. Today I want to present the part is numerical description, measure of registered doctor, dentist, nurse, and community nurse. There are three most commonly used measure of tendency for ungrouped and group data are mean, median, and mode. So in this slide we can see the formula of mean, which is F is frequency, X is midpoint, and the N is sample size. To get the Fx, we can use the frequency multiple the x, which is the midpoint. So we can get the total fx is 54834. So divide the 40. So we can get the answer is 1370.85. In this slide, we can see the formula of median. The LM is lower class boundary of the median class, and the Fn is frequency of the median class. For the Fn minus 1 is cumulative frequency before median class, and for the C is class size. So we will go to the step 1. Step 1 is to determine the location of the median class. So n divide 2. Our n is 40, so divide 2. We will get the 20 observation. Therefore, the median class is 2 until 1075. So we go to the step 2, determine the lower class boundary, which is 1.5. And we go to the step 3, determine the class size. The class size is upper class boundary minus lower class boundary. So we can get the answer is 1074. We go to the step 4, which is to determine the cumulative frequency before median class and frequency of the median class. For the cumulative frequency before median class is 0, and for the frequency of the median class is 22. So for the last step is calculate the median. We use the formula in the slide, and we get the answer is 977.864. In this slide, we can see the formula of mode. LM is lower class boundary of the model class, and this is the difference between frequency of the model class and the frequency of the class before model class, and this is the difference between frequency of the model class and the frequency of the class after model class, and the C is class size. So we will determine the location of the model class. We will base on the higher frequency, which is the frequency is 22 is a higher frequency. So the model class is 2 until 1075. We go to the step 2, determine the lower class boundary. The lower class boundary is 1.5. And the step 3 is class size. The class size we get is 1074. So the step 4 is determine the difference between frequency of the model class and the frequency of the class before model class. So we get the answer is 22, and determine the difference between frequency of the model class and the frequency of the class after the model class is 10. So we go to the step 5. Is the last step is we use the formula in the slide. Then we get the answer is 739.875.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nora Mira binti Adanan, memory number A20A1627. Today I will present about numerical description measure. Okay, numerical measure is a variety of numerical measure are used to summarize data. The proportion or percentage of data value in each category is the primary numerical measure. For qualitative data, the mean, median, mode, percentage, range, variance, and standard deviations are the most commonly used numerical measure for quantitative data. Okay, quartile divide the data value into 4 parts. The first quartile is the 25 percentile, the second quartile is the 50 percentile, and the third quartile is the 75 percentile. To determine the measurement of position, the data must be sorted from lowest to highest. Okay, in this slide, you can see the quartile. Step 1, quartile 1 equal n divided by 4 equal 40 over 4. So the answer is 10. Next is for the quartile 3 equal 3 and divided by 4. So the equal 3 times 40 over 4. The answer is 30. So you can see this is the answer for the quartile. Okay, next the range. The range is the difference between the largest values and the smallest value. It's the simple measure of variability in the data. The range is determined by only the two extreme data values. Okay, the data values, the variance, and the standard deviations. On the other hand, are measure of variability that are based on all the data and are more commonly used. Equation 1 shows the formula for computing the variance of a sample consisting of n items. In applying equations 1, the deviations or difference of each data value from the sample mean is computed and square. The square deviation is the square root of the variance because the unit of measure for the standard deviation is the same as the unit of measure for the data. Many individuals prefer to use the standard deviation as the descriptive measure of variability. Okay, in this slide, as you can see, the formula given, maximum data entry minus minimum data entry. So you can get the range. Okay, next is the formula for the variance, and this is the formula for standard deviation. Okay, last but not least, the shape of distribution. Okay, the shape of distribution describe the population with the same mean and the standard deviation, which can still have distribution with every different shape. Okay, the shape of distribution that show in this slide is skewed to the right, where tail extend to the right. Okay, this is the shape of distribution that show in this slide about is skewed to the right, where tail extend to the right. And that's all from me. Thank you.
My name is Warnor Hafiza binti Waruslan. My metric number A20A2075. For the statistic analysis using SPSS, numerical descriptive measure, there are two tables. This table we use SPSS and this table we calculate with manually. For median, mean, mode, standard deviation, variance range, there are different value between this table. For minimum and maximum, we got the same value. We use percentile 25%, 50%, and 75%. For the quartile 1, we got 489.682. Quartile 3, we got 1791.5. For the hypothesis testing, objective to test the relationship between the state with the number of registered staff types. We use this table, and for the step 1 hypothesis, H0 equal mu1 equal mu2 equal mu3. HA, at least one of the mean is different from the others. For the step 2, significant level, denoted by A alpha equal 0.05. For the step 3, test statistic, we use ANOVA table, the number of registered staff type between group and within group. And we got total 8370641.975. For the step 4, decision rule, reject hash null if f bigger than f alpha, value 1, value 2. Critical region f 0.005, 4, 35 equal 2.64. For the step 5, decision, fail to reject hash null since f less than f 0.05, 0, 4, 35, 0.936 less than 2.64. Therefore, there is no significant difference among the treatments. The result from SPSS F is 0.936. So the treatment mean are the same. This is because the independent variables are discrete valued and categorical variables, other words, depend variables not influenced by independent variables. For these numerical descriptive measure coefficients, based on the standard beta coefficients, the effect of hospital is negative 0.503, which is lower than the effect of state, negative 0.288, The p-value for hospital is less than 0.001 and state is 0.038 less than 0.05. Hence, hospital and state are a significant predictor of number of registered staff types. The 95% confidence interval for hospital is negative 2240.789, negative 670.514, and state is negative 572.575, negative 17.400, where the value of 0 does not fall within the interval, again indicating hospital and state are a significant predictor. The VIF values are below 5, indicating that there is no problem of multicollinearity. That's all from me.
Hi everyone, my name is Patience. My machine number is A20H1SS. Today I would like to present about correlations analysis. These are the results of SPSS. The correlation table is between the number of registered staff type, hospital, and stage. Between the number of registered staff type and hospital implies that there is no correlations between these two variables because the value is near 0. Whereas the value of number registered of staff type and stage is 0.071. Implies that they have correlations between these two variables. But the next table is model summary. The R-square value is 0.336, which means that is 3.6% of the variations in the number of registered staff type can be explained by stage and hospital. The grouping version strategy of 2.933 is not too far from 2. The grouping version statistic is used to test of the presence of sensory correlations among the residue. Grouping version statistic is approximately true, indicates no serious correlations. Confidence interval. The 95% confidence interval that 0.05 significance level can be read confidence level. By using SPSS, the results show the lower boundary and the upper boundary. Therefore, it can be said that 95% confident that the population parameters is between 1138.28 and 2715.82. The standard error for this dependence is 376.855. Theoretical modeling. The model of multiple linear regressions is shows like this. Y is the value of the dependence variable. B0, B1 are parameter. S1, S2, and X are known constants. The symbol like E is the error term. In this case, our Y is the number of registered staff type, which is dependence variable. Two independent variable was considered. S1 is referred to the hospital, S2 is referred to the stage. Based on the coefficients table, the multiple linear regressions is y equal to 4,267.663 minus 1,455.650 hospital minus 294.988 stage. From the equations of multiple linear regressions, we know if 4,267.663. When the hospital and stage are 0, the number of registered staff type will be 4,267.663. Thus, for every unit increase in hospital, the number of registered staff type will drop by 1,455.650, provided the stage remain unchanged. Similarly, for every unit increase in stage, the number of registered staff type will drop by 294.988 units, provided the hospital is still at the same. That's all is my presentations. Thank you.
In conclusion, we use some methods such as data arrangement, graphic method, a measure of tendency, and measure of position to calculate the data, the number of statistics of registered doctor, dentist, nurse, and community nurse by state throughout Malaysia in 2015. For the graphical method, we use two types of graphs such as histogram and OGIF, and we use a measure of central tendency to calculate mean, median, and mode. As a first step, to arrange the data given, we use frequency distribution to calculate the number of classes. For measure of gradation, we use range, variance, and standard deviation. The quartile method was used to calculate the inner quartile range for the measure of position. Therefore, for the statistical Microsoft Excel and statistical package for the social science SPSS, In this part, we enter the data and search for the result. For the comparison in measure of the central tendency, position, and variation. For the hypothesis testing, there is significant difference among the groups, so it needs to reject the whole. For the correlation, there has correlation between two variables. And for the last part, which is theoretical modeling, we make theory based on the formula and just models it with explanation. And we use a multilinear regression in the theoretical modeling. So that's all. Thank you for watching this video.